My name is Dr. Ilana Wisby. I am a deep tech entrepreneur and the CEO of Oxford Quantum Circuits. Today, I'm going to be talking to you about seamless quantum compute as a service and what that really means. Now, at OQC, we really see a world that's very much focused on getting quantum into the hands of humanity, hence the beautiful hand on my side, holding quantum and doing that as quickly as we possibly can, because we really understand that in order to bring that quantum future forward, people need to be able to have access to it. They need to be able to interact with it, to learn and to test it in production, not just in the lab environment. So I'm going to share a bit more about what that really means as this seamless quantum compute as a service piece to you today. Now, before I do that, I'd like to introduce you a bit further into what OQC are doing, and hopefully, there we go, next slide, excellent. So we're originally a spin-out from the University of Oxford. We span out 5 years ago, so we're over 5 years old now. And we build end-to-end systems. So we build quantum computers right the way from the processor all the way up to the cloud. We are a pure-play quantum compute as a service company. And we are a team now of around 80 people, and our core technology is a superconducting circuit. So it is a superconducting quantum bit. That's the proprietary IP that span out from the University of Oxford. It is called the coaxmon, and the coaxmon is effectively a transmon in terms of physical type of qubit. It is coaxial in design. So what we've done is taken that transmon architecture, and instead of doing something that existed within academia and then scaling it up very, very rapidly, what we did was really take a step back and think, how would we redesign that core qubit transmon processor and think about what that would look like at a commercial level if we were to try to optimize it, thinking about scale, thinking about quality, thinking about flexibility from first principles. And that really led us to this core innovation that our founder, Peter Leak, patented all those years ago. So as you can see, it looks quite different. Normally, a qubit transmon is like a cross, like this. Instead, we are circular. So we have this coaxial-shaped design. So we have an inner and an outer with a Josephson junction in between that sits on one side of a silicon or sapphire wafer. And then on the other side of the chip itself, we then have our readout resonator. And our resonator is also coaxial in design, so that it's beautifully mode matched to our qubit in that same circular geometry. What we can then do is take our control and our readout wires and we can bring them either side, above and below, never physically galvanically connecting or touching that actual chip itself. And then you have completely 3D out-of-plane control that's incredibly simple, incredibly elegant. You can take that unit cell and you can scale it into larger and larger processors without having to mess around with flip chips or through silicon vias or any type of air bridges or things like that. So it's very simple, it's very elegant, it's very scalable, and it's very flexible. And that really does underpin everything that we do as our quantum core. Now that, of course, sits at the bottom of our stack. So we've got our quantum processor there, our QPU. Above that, we also have our control hardware, our control software, and then we have a lightweight QCAS platform. We really try to take that ethos of being simple, scalable, and flexible across every level of that stack and everything that we do. Employing that strategy and based off that technology, we have already delivered Lucy, and Lucy is our latest quantum computer that is commercially available. She's available on both private as well as public cloud access, and I'll tell you more about that in a moment. She's an 8-qubit processor. We have custom control around it. We've also got OpenQASM support, and recently we launched OpenPulse, so you can also have pulse-level control of Lucy with your work. Why Lucy? Well, all of our systems are named after pioneering female scientists. So for those of you that are interested, Lucy currently is a circular configuration, so a topological ring. I've got some parameters here. I think they're from summer, some latest metrics. But I must say, Lucy's getting quite old. She's been online now and cold for over a year, and she was fabricated probably in April of the year before. So she's old technology, and we're really excited to be able to launch newer technology and share more about our R&D and latest parameters with you, hopefully very, very soon. But for now, Lucy is available. She's still really, really good, and we're really proud of to have her available and online. So you can access Lucy through Amazon Web Services. She's been online since February on Amazon Web Services. So if you log on to AWS Bracket, you can drop down and pick OQC and start to run algorithms on Lucy anytime between 10 o'clock and 1 o'clock UK time. That was actually a European first. And that was actually something that was really important to have that European endpoint, because there wasn't any other systems that were available in Europe at that time. Prior to that, you'd have to use an American system. And if you start to think about data security for many customers who were based in Europe, things like GDPR, data sovereignty, data onshoring, these were like top of people's minds. So making sure that we had a system that was available with a secure data endpoint in Europe was really important for both us and also for customers and for AWS. You can also access Lucy directly through our private access. I'm going to talk about more about this later, but with this we can and we have already delivered private POCs with governments, with financial institutions, and with that we can provide a bit more support. So we all know, we're all here at Q2B, we recognise that quantum is something that we all should be thinking about. 97% of executives believe that quantum computing will disrupt their sectors to a high or a moderate extent. This is from an EY quantum readiness survey. Now, the next stat's interesting. 48% of executives believe that quantum computing will reach a significant maturity to play a significant role in most companies by 2025. Now, I'm going to say I don't personally think that number is correct, i.e. the year, 2025. I'm curious. If you think, do you think that's accurate? Put your hand up if you think that's accurate. 2025? I can't see a single hand, so either I can't see anything or nobody else believes that too, so I'm in good company. Right, next question. How many people here have used a quantum computer? Oh my gosh, that's awesome. So normally when I do this, my next slide makes sense. Because I go, what's going on? Because normally it's like 20%. But actually that was probably like 80% of the room, which is incredible. How many of you have used Lucy? All right, let's try and get that number up later, huh? Excellent. So what is going on? Well, actually, if we go back to the EY report, only 24% of companies have, or executives have got these type of programs dedicated to quantum going on. So there are clearly restrictions in why pilot schemes aren't happening more often, considering the fact that people do recognize the importance and the prevalence of it. So what do we hear? We often hear, we need help. Our team are really smart, but they need support getting quantum ready. This is a huge thing, the learning piece. How do I get quantum ready? How am I going to access it? Okay, it's online, but I don't necessarily know what code to run. I need more support. That's one thing that we hear time and time again. Another thing we hear is that we hate queues. People hate queuing. Yeah, we're British, we're okay at queuing, but other people really hate queuing. And actually, I also hate queues in a quantum sense. So they want to start to think about running hybrid algorithms often. So for that, you need super low latency with classical and quantum control and interconnects, or between the two of them. Right now, that's quite difficult to do effectively in terms of the access. So latency is a huge problem. Final one, I hear this so often. But my data can't leave the building, right? I want to run something. I want to run real data on a quantum computer, but my data can't leave the building. Ilana, how much does it cost to buy a quantum computer? I then tell them how many million of pounds it would be. And I go, that's not part of our strategy. We're a pure play quantum compute as a service company. I don't think that you really want to buy a quantum computer. But this is what they often hear, and it's from that perspective of security. It's from that perspective of, like, my data physically can't leave the building, and I need to know that it's at a secure data endpoint, and even accessing through public cloud, like many companies are still getting comfortable with cloud today, even though it's something that should be secure, they have very few trusted partners. So making sure that people are able to convince their key stakeholders that the data is being held in a secure space is really important, and again, a big barrier to entry. So to that end, at OQC, we want to seek to mitigate those challenges, and we're doing that by enabling seamless quantum compute as a service. Now, what does that mean? Well, first of all, it means no queues. It means 24/7 access. It means making sure that we can integrate quantum computing as a service into customers' existing data infrastructure and solving the two key challenges that we hear about time and time again, access and learning. So we're doing that in two ways. Firstly is through OQC Live. Now, OQC Live is integrating quantum computing into the existing world's digital infrastructure. Enough of that jargon. It is into data centers. We are already putting quantum computers into data centers around the world today. Now, that means that you have the physical system in the data center that has already got all of the customer secure endpoints there. So when customers say our data can't leave the building, what that actually means is it can't leave our secure data endpoint. And that extends to their secure and trusted data centers. So we're already at that point. What we can also do is make sure that you then have super low latency interconnects between your classical compute and your quantum compute, because they're physically right next to each other in the same building. We can also connect without touching the public cloud, because you can have direct interconnects, and we can connect directly through dark fiber as well. So really solving that problem of data surety, data security, low latency, no queues, 24/7 access, seamless quantum compute as a service. Solving that problem of access, which is a huge barrier to entry, and testing quantum computing in production today, because this is how you will be interacting with it in the future. We need to understand how that works. We need to get testing. We need to break down those the barriers and understand how that will work as quickly as possible to get it into the hands of customers. Now, this is not simply a vision. It is something that is actively happening. We've recently announced our partnership with 6TeRa, and right now our next generation system, Lucy's sister, who is a 30-something qubit processor, is being actively deployed into a data center just outside of London Heathrow, which is a 6TeRa site as we speak, which is so incredibly exciting. And 6TeRa are really excited about it too, because as far as we understand, that's a world first. And there's a lot more to come as well. We're rolling this model out with other leading data centers across the world. And we'll be excited to share more about that in the future as well. So access is one, learning is the other. So how are we addressing the learning problem? Well, we're doing that with OQC Labs. Now, OQC Labs is much more about helping users with that journey, with that learning on-ramp, to support customers to learn how to use that and enable them to experiment with use cases, initial use cases today. Right? And we can do that in our R&D environment, or we can do that in our production environment in the secure data centers. But you can work hand in hand with our quantum engineers. We also have quantum algorithm experts. They can support you and handhold you through that first learning journey. Now, many people need that, many people don't need that. But either way, we can provide different premium feature sets as well around how you can understand as much as possible. So, for example, analog data is something that lots of our customers are interested in, so that they can really understand what's happening at that level of quantum computing. And they can experiment, so we can support this. We're happy to be flexible. We're happy to do co-design. One of the key advantages of the Coaxmon is the flexibility of the connectivity of the processors. We can map algorithms onto processors if that's something that's interesting to you. There's really a ton of things that we can support. So it's through learning, through access, through experimentation that we can support with that as well. Now, we also do this through partnerships. So we don't try to do absolutely everything ourselves. So if there are partners that you trust and you want to work with to support algorithm development, that's something that we support as well. So we do have partnerships with various algorithm developers, but we primarily understand that the customers want to own their algorithms, they want to own that sensitive IP, and actually what we want to be able to do is support customers learning in that directly or through various partnerships. Again, more on that announced maybe next year. So across that, we'll be able to partner with pretty much every single market vertical. So if any of these look familiar to you, we are looking to do some POCs or continue to do POCs across all of these different areas. I've got Gerald Mullally, who's our lead partnerships. He is here with me straight after this session. There is a booth that's right at the back of the room, hosted by the FCDO, very kindly, the UK government. And Gerald will be there, and he'll be really happy to talk to you more about different partnerships and ways that we could look at working together to experiment, either through OQC Labs or through OQC Live as well. So really, that will enable us to put quantum computing at the customer's fingertips, get it into the hands as quickly as possible to deliver on that vision, to enable them to make these breakthrough discoveries that are so important so that we can prove business applications, business use cases as quickly as possible. And with that, I'd invite you to join us to pioneer the quantum revolution. You can either partner with us. If you do that, that will send Gerald an email. So if you don't want to see him at the booth on the left, you can send him a quick email, arrange to have a coffee with him or myself. If you're interested in joining us, we are still expanding. So across the world, we've got new positions opening up in Japan, as well as in the UK. We're expanding both on technical and non-technical skills as well. And with that, I'd like to say thank you. We do see a brighter future for all that is enabled by quantum. I have 3 minutes for questions. Does anybody want to ask anything? I see a hand.
Yeah, forgive my ignorance, but I'm just curious, who is Lucy named after?
Oh, so Lucy's named after Lucy Mensing, who is a German quantum physicist. Our first system was Sophia Jex-Blake, so that was one of the Edinburgh 7. Our next one, I can't tell you yet, but it has a Japanese theme.